Sometimes we'll be looking at two triangles and we need to prove them congruent, but we won't have enough information. But what oftentimes happens in some of these proofs is that the triangles that we're trying to prove congruent, they have corresponding parts that would also be corresponding parts of other triangles in the diagram that we might be able to prove congruent. So why is this helpful? It takes you a minute to kind of wrap your head around what this is saying right there. But why would that be helpful? Let's take a look at this diagram. Suppose we needed to prove that segment AB is perpendicular to segment AED there. So just to kind of draw our attention to that, let me just highlight that we want to prove that these two segments are perpendicular to each other. All right, so that's what we need to do. How could we use angles 3 and 4 to do that? So if I look at angles 3 and 4 here, what would I need to know about angles 3 and 4 that would make these two orange highlighted segments perpendicular? Well, if you remember back a few lessons, we learned that if these two angles, which are adjacent, if they were congruent to each other, right, that would mean that they're both 90 degrees because together they make up a straight line. So together they make up a straight angle. If they happen to be congruent, then we would know that they would both be 90 degrees. So if I can figure out, how could I use angles 3 and 4? If angle 3 was congruent to angle 4, then AB would have to be perpendicular to ED, right? So now I would think, okay, are angles 3 and 4 corresponding parts of any triangles? Because that's one of the things that we've been doing is using CPCTC to say that corresponding parts are congruent. So are 3 and 4 corresponding parts of any triangles? And you'll notice that they are. They're corresponding parts of triangle DAC and DBC, right? These two triangles right here have angles 3 and 4 as corresponding parts. Yep, so they are corresponding angles for triangle ADC and triangle, ADC and BDC, right? So, as of right now, we don't have enough information to prove those two triangles congruent. So it seems like we're stuck. We realize that if we could prove these triangles congruent, we could say that angles 3 and 4 are corresponding parts that are congruent, and if 3 and 4 are congruent, it means they're both 90, and that would lead us to say that the two orange segments are perpendicular. But it doesn't look like we have enough. What do we know about those two triangles, right? We know that angle 1 is congruent to angle 2, and we would be able to say that DC is congruent to itself by the reflexive property. But that's only two of the three things that we might need. What else could we use? And I gave you a hint here. If we wanted to use SAS to prove that these two triangles are congruent, we have one pair of angles and one pair of sides. The other pair of sides that we would need for side angle side would be that segment AD congruent to segment BD, right? If we had that, then we could say that these two triangles are congruent, which means we could say that angles 3 and 4 are congruent, which would mean that we could say that the orange segments are perpendicular. So, are these two things corresponding parts of any triangles, any other triangles besides the ones that we are hoping to prove congruent? And we notice that they are, right? They are AD and BD are corresponding sides of triangles DAE and DBE. Okay, see that? DAE and DBE both use these two sides as corresponding parts. Can I prove that those triangles are congruent? I can, because look, I have angle 5 congruent to angle 6, right? Triangle DAE is going to be congruent to triangle DBE because angle 5 is congruent to angle 6, so that's one pair of angles. Angle 1 is congruent to angle 2, that's another pair of angles. And they share segment DE, so it's congruent to itself. That's the included side between those two angles. So therefore, angle, side, angle can be used to prove that those two triangles are congruent. So if those two triangles are congruent, DAE and DBE, then AD is congruent to BD by CPCTC, which would mean that triangle ADC is congruent to triangle BDC by side angle side, right? Because now we could mark that, I'll use blue, we could mark that this is congruent to this, and now I have a pair of sides, included angles, and then this other side for these two triangles. And if ADC is congruent to BDC, then angle 3 is congruent to angle 4, which would make them both right angles. So maybe I'll use the right angle symbol to mark that, right? This would be congruent to this, and they're both right angles, which would mean AB is perpendicular to ED. That's a pretty involved proof. There's a lot of steps to that proof, but you can see how this idea of using more than one pair of congruent triangles could lead us to a point where we're trying to get to. Let's take a look at another example. In this picture, we have that angle 1 is congruent to angle 2. Right, angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. And our job is to prove that TU is congruent to TW. Well, I noticed that TU and TW are both corresponding parts of triangles TSU and TSW. But I don't have any other information about those. I do know, right? I do know that TS is congruent to itself. And if angle 1 and angle 2 are congruent, that would mean that this angle right here, I shouldn't use 2 marks because I already used that. I'll just go, this angle would be congruent to this angle if 1 and 2 are congruent. And then if I could have this piece of information right here, so I'll mark it in yellow, if I could say that this is congruent to this, then that would give me side angle side for these two triangles. Well, does this given information, does that allow me to say that these are congruent? Well, it actually kind of does, right? Because if these two angles are congruent, and then this thing is congruent to itself, I got to use 4 marks. I'm using a lot of side marks on this diagram. This would be congruent to itself, segment SV. So I had angle side angle for these two, which would make the marks that I've done in yellow true, right? US would be congruent to SW, which would give me side angle side for these two, and then TU would be congruent to TW by CPCTC. So let's look at what that looks like in a proof. This is a pretty tricky one, but I think we can do it. So first of all, we are going to say that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, because that's given. Next, we're going to say that SV is congruent to itself by the reflexive property. That allows us to say that triangle USV is congruent to triangle WSV using angle side angle. Now, what we can do is say that segment US is congruent to segment WS by CPCTC, right? So if I'm kind of following this along, I had a pair of angles here and a pair of angles here and a pair of sides here. These three things, they all led me to say that angle side angle was true for this thing. Now I'm starting down a new path. Now I'm going to start down a path that says that this is a pair of sides, right? Right here, and I know that ST is congruent to itself. That's another pair of sides. And lastly, I can say that, well, in order to say that these two angles are congruent, I got a little work to do. I got to say that the measure of angle 1 plus the measure of angle UST has to equal 180, and that the measure of 2 plus the measure of angle WST also equals 180. That is, oh, I forgot to put a reason here for step 5. Sorry, you guys probably figured that out. That's the reflexive property. Okay, so back down here. Those two things add up to 180 by the angle addition postulate. But now if they both equal 180, I can say that the measure of 1 plus the measure of angle UST equals the measure of 2 plus the measure of angle WST by substitution. Substitution property. But now since I've set up here that angle 1 and angle 2 are congruent, I can subtract off the angle 1 from 1 and the angle 2 from this other side, and that would leave me with the measure of angle UST equals the measure of angle WST, otherwise known as angle UST is congruent to angle WST, and that is using subtraction property, and that is our pair of angles that makes these two triangles congruent. So now I can say that triangle TUS is congruent to triangle TWS by side, angle, side, right? And if those two triangles are congruent, our last step here is to say that TU is congruent to TW by CP, CT, C. So there you go. It's a pretty long proof, right? And you might have to rewind this and take a look at it again. But we're using two sets of triangles to prove that these two segments end up being congruent. Using one set of congruent triangles to give us a piece to prove the other set of congruent triangles congruent. Okay?